Okay. Okay. Just thank you everyone for staying around, and I also like to thank Joan for giving me the opportunity to present in this event. So today I'll be presenting on the 3 isometric strength training research that I conducted for my PhD study. So this will be the very first time the data is available to the public. So I hope you will enjoy this presentation. So isometric strength training is a mode of strength training that involves exerting of force by the muscle without any movement. So one example is pushing the wall. You are exerting a lot of force, but you are not actually producing any movement. Other modes, other examples are like the prone plank that we commonly do to improve our core muscle strength. So isometric training can actually be categorized into the overcoming method or the yielding method. Yielding method meaning hold at submaximal contraction, which is like the prone plank. And then overcoming method is usually maximal exertion, like the example I gave you earlier, the pushing of the wall. So my research is mainly on the overcoming method. Some of the advantages of performing isometric strength training include it's generally safer than dynamic mode because of the lack of movement. So there's less risk of injury. Some study has showed that it's less fatiguing in terms of requiring a lower energy consumption. And it's superior in increasing joint angle specific strength. So if someone has problem with a certain movement, what we'll usually do is get them to perform isometric training at the sticking point of that particular movement, because the sticking point is usually the hardest to overcome. So isometric training is best at improving the force production capability at that particular joint angle. And of course, isometric training is superior in increasing the muscular tendon. So the stiffness of the muscular tendon. The tendon stiffness is very important in transmission of concentric force. And also if the tendon is stiff during the stretch shortening cycle, which is during the eccentric phase. If the tendon is able to be stretched further, then because of its stiffness, the recoil will also be greater. Right. So that helps with jump performance as well to a certain extent. Okay. So apart from improving strength, muscular strength itself, some study has also shown that isometric training can enhance jumping performance, but the effects on concentric only jump, meaning there's no counter movement, is well evident, but the effects on counter movement jump is still debatable. Right. And some other studies has also used isometric training to improve, to see if the isometric training can enhance running performance, soccer kicking performance, as well as cycling. The most recent study is by this group of researchers, Cody and colleagues. So they had this group of elite cyclists perform isometric training, and they actually found that the isometric training was more effective than the traditional strength training in improving cycling performance. But of course, the isometric training they did was specifically positioning the cyclists at the cycling position. So it's a very specific cycling, sorry, yeah, it's a very specific training, and it's not like the general strength training we do with squat and so on. So there's also movement involved. So coordination of the motor units was better. So what we know so far, performing of the rapid contraction during isometric training can help to increase explosive strength. So it's quite similar to normal strength training, whereby if you want to increase your power output, you will try to contract your muscle as explosively as possible, irregardless of whether you're lifting heavy or light loads, right? And the next thing we know about isometric training is if we sustain the contraction at maximum contraction for a certain period of time, we will increase maximum strength more than if we don't sustain the contraction. Meaning you can contract explosively with maximum intensity, but you don't sustain that contraction. So again, this is quite similar to dynamic mode of training, whereby if we do more repetition in total at whatever load it is, the strength increment theoretically will be higher. Right? And the next thing we know is one of the misconceptions about isometric training is that it will only increase strength at that particular joint angle that it was performed at. But if we perform the isometric strength training at a position that induces long muscle length. So for example, what I meant by long muscle length is if you flex your knee to 90 degrees versus if you fully straighten your knee. So if you fully straighten your knee, your quadricep will be contracted. But if you flex your knee to 90 degrees, your quadricep will be slightly stretched. So that induces a longer muscle length as compared to a fully straightened knee position. All right. So that's what I meant by joint position with longer muscle length. So if we do that, we perform isometric strength training at joint position with longer muscle length, we can actually increase the range of movement whereby strength will increase. And of course, we also know, as I presented just now, that isometric strength training can help to improve jumping, running, kicking, as well as cycling performance. So what do we not know at this point of time? Question is, what is the most effective isometric strength training loading method to improve the neuromuscular performance, sprinting, as well as jumping performance? Second thing is, we know that isometric strength training can enhance endurance running performance, but what is the effect as compared to plyometric training? Because plyometric training is, if endurance runners even do any form of resistance training, they are more likely to do plyometric training because there's this fear of increasing muscle mass from heavy weights training. While if we are experienced in strength training, we know that it's not so easy to gain that muscle mass. And finally, strength training is an integral part of sprint carcass, and they have been performing traditional strength training. And we know that carking is, in terms of muscle contraction, carking is similar to cycling, whereby they lack the eccentric movement. So carking and cycling mainly involve concentric muscle contraction. So if isometric training can enhance cycling performance, there's a very likelihood that isometric training can also enhance sprint carking performance. So these were the three questions that led me to my PhD research. Let's take a look at the first study. Give me a minute. So the objective of the first study was to compare the effects of two isometric strength training method on dynamic performance, mainly sprint and jumping performance. So what we compared was the explosive contraction method. So we got the participants to contract muscle explosively, but they do not sustain that contraction. The other method was explosive and yet sustained. So they contract their muscle maximally and they sustain each contraction for 3 seconds. Right? So we hypothesized that the explosive, both method will improve dynamic performance, meaning the sprint and jump, but the sustained contraction method will increase strength more than the explosive only method. So for this study, we recruited 33 male and female national floorball athletes. They were randomly assigned to a control group, the explosive group and the sustained training group. And they came for one familiarization session, one pre-test, one post-test, and 12 training sessions over a period of 6 weeks. The tests involved were counter movement jump, 30-meter sprints, isometric squat at 90 and 120-degree knee angle. So this is the counter movement jump test. It was performed on the force platform. So we used the force plate to analyze the jump power as well as calculate the jump height. This is the 30-meter sprint. So the sprint time was analyzed by the light gate. So every time they pass through the light gate, it will estimate the time that it will measure the time that they took to run the distance. And this is the isometric squat. It was also performed on the force plate. So the athlete had to exert as much force as possible against the bar that was fixed at that position to allow her to adopt the 90-degree or 120-degree knee angle. And then the force plate will actually measure the amount of force she produced and also how fast she produced the force. So this was the simple training program the athletes went through. For all groups, they had to perform this set of exercises. So it was 2 to 4 sets and 6 to 10 reps. For the isometric training group, they performed 90 and 120-degree isometric squat at 90 and 120-degree knee angle. 2 to 3 sets for each knee angle. For the explosive group, they performed 10 repetitions and there was only 1 second of contraction. For the sustained group, they did 5 repetitions and sustained each repetition for 3 seconds. So the way they performed the isometric training was exactly the same way they did for the test. They had to be explosive and produce maximum force right from the start. And so after the 6 weeks, we did a post-test for them, and this is the result. What we found was that both the isometric training group actually improved their jumping performance. No change in jumping peak power, but jump height was significantly improved. Both isometric group in terms of percentage change were significantly higher than that for control group. but there were no significant difference in the percentage change for either of the groups, either of the training groups, sorry. When it comes to sprint time, there was no significant change for the explosive isometric group, but there was a significant improvement in the sustained isometric training group. So you can see from here, the graph shown on the left, you can see that the 3 seconds contraction group, which is the SIST, actually had greater reduction in sprint time. So meaning they became faster and took less time to complete the 30-meter distance. No, all groups did not have any significant change in the sprint peak power. Okay, in terms of maximum strength measured using the isometric squat, both groups improved, both isometric training group improved the peak force as well as rate of force development, meaning how fast they can produce the force at both squat and at both 90 and 120-degree knee angle. So this is the graph for the percentage change for peak force over here on the left and rate of force development on the right for isometric squat at 90-degree angle. Although we can see that the SIST group seem to improve a lot more than the, typo error here, EIST group. In terms of statistical difference, there wasn't any. Same thing, there wasn't any statistical difference in terms of rate of force development. But if we look at the effect size calculation, there was a moderate effect, meaning that the sustained group was had a moderate positive effect over the explosive group. Over here, we can see that the peak force and rate of force development during the 120-degree knee angle isometric squat. Again, there was a slight advantage of using the sustained isometric protocol. Right? Okay, in conclusion for this study, both isometric group improved strength and jump performance, but only the sustained isometric group improved sprint performance. And there was a moderate effect in terms of percentage improvement when we compared the sustained group and the explosive group. So sustained group had a greater improvement in strength. One of the problem for this study was that we did not equalize the total time of contraction for both groups. So in the end, the sustained training group had a 50% longest contraction time compared to the explosive group, because sustained contraction did 5 times 3 seconds, and the explosive group did 10 times 1 second. So that was a 50% greater in training volume. So this might be one of the reasons why we see a greater strength improvement in the sustained isometric training group. Right. So that was study 1. We're going to move on to study 2. Study 2 was the study where I compared the effects of isometric strength training with plyometric training on 2.4 km run performance. The reason why I chose 2.4 km run was because it's a valid test for aerobic fitness, and it's also a running test that is familiar to most Singaporeans, I would say, right? And we hypothesize that isometric training will have similar improvement in running performance as plyometric training. In this study, we recruited 24 male and female endurance runners from the public. They were then separated into assigned randomly to the control group, isometric training group, as well as the plyometric training group. They did one familiarization session. So during the familiarization session, we had to get them to attempt performing the pre-test, like counter movement jump and isometric mid-thigh pull. They were also familiarized to run on the motorized treadmill with the gas mouthpiece for the VO2 max analysis. Right. So during the pre-test on the motorized treadmill, they actually perform two tests: the running economy test at either 10 and 12 km per hour for female, or 12 and 14 km per hour for males. And after that, they perform the VO2 max test. And after the pre-test, they came for training twice per week. So this is the position, the setup for isometric mid-thigh pull. So it is the position of the second pull during the power clean exercise. Same thing as the isometric squat. What they need to do is drive the force down on the force platform with their legs. So it's almost like also similar to the end range of movement of a deadlift. And for the treadmill test, as I mentioned earlier, they performed the running economy test. For female was 10 km and 12 km per hour. For male is 12 km and 14 km per hour. What they did was run at those speed for 4 minutes while we collect the air they breathe out, and using it to estimate the energy consumption. So after the running economy test, we got them to rest for 6 minutes before we got them on back on the treadmill to perform the VO2 max test to measure the maximum oxygen consumption, as well as to obtain the maximum aerobic speed. So the final speed completed was deemed the maximum aerobic speed. For the VO2 max test, what we got them to do was run on the treadmill starting at 8 or 9 km per hour. And then every minute we increase the speed by 1 km per hour. And this goes on until they were too exhausted to carry on. This was a simple training program that the runners had to perform. So for the control group, they did a mini circuit of body weight squat, single leg Romanian deadlift, as well as rear lunge. And because it's over 6 weeks, they performed 3 sets of 30 seconds for the first 2 weeks, 3 sets of 40 seconds for week 3 and 4, and then 3 sets of 50 seconds for week 5 and 6. And for the plyometric group, they did drop jump, single leg bounding, and alternating split jumps. This was progressed for drop jump. It was progressed by increasing the drop height. Single leg bounding and alternating split jumps was progressed by increasing the load they have to hold. So for the first 2 weeks, they were just jumping with their body weight. And then for week 3 and 4, they had to hold on to 5%, extra 5% of their body weight. Week 5 and 6, they held on to extra 10% of their body weight. And for isometric training group, we use the same protocol as the sustained isometric contraction I mentioned earlier for study 1. And it was progressed from 3 repetition for first 2 weeks, 4 repetition from week 3 and 4, and 5 repetition for week 5 and 6. The exercises they performed were the isometric mid-thigh pull as well as the isometric calf raise. So this was how the drop jump was performed. So the focus of the drop jump was to minimize ground contact time. So we want the participant to leap off the ground the moment they touch. So it was actually working on the reactive strength rather than to create a large amount of force. This was a single leg bound. Same as the drop jump, we want minimum ground contact time. And this was the alternating speed jump. Speed jump, we wanted them to go for maximum height instead of working on their reactive strength. The isometric mid-thigh pull was the same as the test. The way of execution was exactly the same as the isometric squat I showed earlier. And this was the isometric calf raise. So this is the position for the isometric calf raise. Participants had to exert force against the bar by attempting to perform a calf raise while keeping the knee and hip locked in position. Again, the way of execution is the same as the way they executed the isometric squat and isometric mid-thigh pull, sorry. Right, so we want them to produce explosive contraction, and right from the start, they should be at maximum rather than slowly building up the force produced. So after the 6 weeks of training, during the intervention training, participants actually carried on with their usual running training. What we did was get them to lock down, record down the run training so that we can compare between groups and make sure that we know whether the running distance actually affect the training, intervention training or not, right? So what we found firstly was that all groups had no significant difference in terms of running mileage per week, right? So on average, they were around 48 km per week. 2.4 km run time was improved in the plyometric and isometric training group, but not significantly improved in the control group. In terms of running economy, it was only improved in the isometric training group. What this shows here is the energy consumed for each km they run, per kilogram and per km. So the lower the value, the better it is, meaning they are actually expending less energy while running at that particular speed. Very interestingly, what we actually saw was that some of the runners were actually more economical when they were running at a higher speed as compared to a lower speed. Not no significant change in VO2 max except for the plyometric training group. We actually wanted them to have no change in, hoping for no change in VO2 max, because VO2 max, VO2 max is a measure of the oxygen consumption, and oxygen consumption actually indicates how much energy was expended. So if they can actually increase the running speed while not increasing the oxygen consumption, that means that's another indication of improved running economy. So over here, running economy was not improved in plyometric training. So it's not surprising to see an increase in VO2 max because there was increase in maximum aerobic speed. Right. So if there's no increase in running economy, that means when the person runs at a higher speed, theoretically, they should be consuming more energy. But in the case of isometric training, there was improvement in running economy. So, but there was no increase in VO2 max, even though they increased the maximum aerobic speed. So again, this is quite expected, because that again indicates the improvement in running economy. So for the 2.4 and running economy graph, negative change means improvement. That means they actually ran faster, less time taken to complete the 2.4 km run. And in terms of RE, negative meaning they are expending less energy running at that particular speed. So we can see in terms of performance change, there was no significant difference between the plyometric and isometric training group, but both improvement were significantly greater than the control group. Although running economy was significantly improved in isometric training group only, but this improvement was not statistically significantly different from the change for both plyometric and control group. And maximum aerobic speed was significantly improved in both plyometric and isometric group, and this change was significantly greater than the control group. Okay, in terms of jump and strength measure, both isometric and plyometric group improved the jumping performance, but only the isometric group significantly improved the isometric mid-thigh pull peak force. Both groups did not improve on the rate of force development, as indicated by the lack of change in the amount of force produced at 100 milliseconds. This is likely because of interference effect from concurrently performing strength and endurance training. Okay, it's quite understandable that plyometric training will improve jump performance more than isometric training, and isometric training improving the strength more than plyometric training. Apart from because of the different mode, this also supports the theory of specificity. Right. And what this also showed is that for individuals who are not strength trained, so most of the endurance runners did not have structured strength training experience. There were a few who were already performing strength training, but most of them were not performing it. And so what we can see from this result is that if someone is not very strong to begin with in terms of muscular strength. If they perform strength training to improve their muscular strength, they can still improve on the dynamic performance like a jump activity. So that further reiterate the importance of muscular strength. So we know that isometric strength training group improve running performance, and the mechanism for this improvement is likely due to improved running economy. But plyometric training group, although improved running performance, but did not improve running economy. So what we speculate is that the reason why plyometric training group could improve running performance was because of the reduced rate of muscular fatigue. So because the muscle don't fatigue so quickly after a period of plyometric training, they can sustain that particular running speed for a longer period of time. And so they were able to run faster for the 2.4. And one of the advantage we see in isometric training over plyometric training is the improvement in running economy. I mentioned earlier there was lack of change in the rate of force development. This was likely due to the interference effect of performing running and strength training concurrently. So previous study have actually showed that there were times whereby the run training will interfere with strength gains. In this study, we actually showed improvement in strength, but some study has showed the lack of improvement in strength when endurance and strength training were performed concurrently. So one of the things we always recommend for individual runners or endurance athletes who wants to do concurrent training is to separate the sessions by a few hours if they are performing on the same day. If they are performing it on different days, then that's not too bad. And for other athletes who are not non-endurance runners, they will likely want to have some form of muscle hypertrophy. Then hypertrophy is not compatible with high intensity interval training. So if someone have the objective of improving their aerobic fitness while still having some form of hypertrophy, then during that phase of training, it's best for them to do low intensity, long distance aerobic training instead of interval training. So the interval training can probably be included in the phase whereby they want to increase their maximum strength or power. And usually if you want to increase, your focus is more on the muscular strength, then you should perform the strength training first. Then after a few hours, you go on to perform the aerobic training. So that's all for the second study. We move on to the final study, which is the study where I included isometric strength training into the sprint kayaking training program. So what we did was compare the inclusion of isometric training with the traditional strength training alone. And we hypothesized that the inclusion of isometric training will improve sprint performance more than traditional strength training alone. So in this study, we recruited 20 male and female national and varsity level sprint carcass, and they were randomly assigned to either traditional or isometric training group. One familiarization session, one pre-test, one post-test, and 12 training sessions over 6 weeks. During the pre and post-test, they had to perform isometric squat, isometric bench press, isometric bench pull, and 200-meter kayak ergometer sprint. The reason why we chose kayaking on ergometer instead of actual on water was to avoid any confounding factor due to weather conditions. And one of my previous study, we have showed that the mean power obtained from the kayak ergometer sprint was very highly correlated with on-water sprint time. So it was well validated. And the reason why we chose the isometric squat, bench press, and bench pull as the test was also because we found high correlation with force produced during this test with the on-water 200-meter kayaking performance. And because it's much safer and quicker test to perform as compared to 1 RM, we find that this was ideal for measuring the strength. So isometric squat, I've shown the video earlier. It's the same method of performing. For isometric bench press, this is the picture for isometric bench press and isometric bench pull. So what we did was we placed the two benches on the force plate. So when the participant pull or push against the bar, force will be exerted onto the force plate, and that is how we measure the amount of force to produce. Method of contraction again is the same. Explosive, sustain for 5 seconds. Ergometer sprint. So what they had to do was basically sprint as fast as possible on the ergometer. This wasn't one of the participants. This was one of the world champion from Germany. I showed this video because I didn't have the video of our participants doing the ergometer kayaking. So the performance measure for this test was the mean power instead of the time to completion, because every ergometer will have a different algorithm for measuring the time. What my previous study did was validate the mean power obtained instead of the time. So we measured mean power instead. So both group actually did pretty similar strength training, but what happened was the isometric group replaced 2 sets of squat, bench press, and bench pull with the isometric training version. So this is the weekly breakdown. So it was a linear periodization. Every 2 weeks, we increase the intensity. In terms of mean power, both groups actually improved significantly. There was a slightly greater improvement in the isometric training group. When it comes to strength measure, there was no significant improvement in isometric squat performance for the traditional training group. peak force and rate of force development at both knee angles were increased for the isometric training group. Isometric bench press, peak force and rate of force development for both elbow angles were improved significantly for isometric training group, but for traditional training, they only improved peak force at 120-degree elbow angle. Similarly, for bench pull, the isometric training group improved all measures, the peak force and rate of force development at both elbow angles. But the traditional training group only improved the peak force at the 120-degree elbow angle. So based on the current result, isometric training resulted in greater improvement in both kayaking and strength performance. One of the reasons is because isometric training was performed at the position where that was similar to that adopted during the kayaking pull stroke. So I mentioned earlier that the isometric training is able to increase joint angle specific strength more than other modes of strength training. So by positioning the isometric training at the initiation of the pull phase of the kayak stroke, we were able to increase the force production the most at that particular joint position. So if you have done kayaking before, you know that the initial force production has to be high in order to for you to move the boat fast. So if we could increase the force production at the initiation of the pull stroke, that would be of great advantage to the kayak athlete. And that was what we did, get them to be at the similar joint position for both the lower limb as well as the upper limb. And that was possibly why we see a greater improvement for the isometric training group. Another reason was because participants were, all the kayakers, they were well accustomed to traditional strength training, and this might have resulted in diminishing return. So you know that if you perform the same form of training over time, you won't see as much improvement as before. So apart from allowing participants to exert maximal force during the isometric training, the isometric training also provided a variation in training. And this variation in training could have helped to reduce any plateau in improvement. And one of the advantage I mentioned about isometric training was the improve in tendon stiffness. Kayaking is mainly involve concentric contraction, which will highly benefit from increased tendon stiffness, as isometric training is known to have greatest effect on tendon stiffness among the different modes of strength training, including the isometric training into kayakers strength training regime might be something for coaches to consider. So in conclusion, isometric training performed with rapid, maximum, and sustained contraction resulted in greater strength gain as compared to a non-sustained protocol. This was what we found in study 1. And in study 2, we found that isometric training was as effective as plyometric training in enhancing running performance. The mechanism for this improved running performance was likely due to the improvement in running economy after isometric training. And what we also found was that isometric training was more effective in improving maximum strength, but less effective in improving jump performance as compared to plyometric training. This is what is we would have expected due to specificity in training and the different modes of muscle contraction. And for the third study, what we found was that if you replace part of the dynamic training with isometric training, like what we did in study 3, you can actually increase strength more than just simply doing traditional strength training. So based on these 3 studies, what we found was that isometric training can enhance performance of movements involving both eccentric and concentric contraction, and also movement that involve mainly concentric contraction. So the movement that involve eccentric and concentric contraction were jumping, sprinting, as well as running. And the movement that involved mainly concentric muscle action was kayaking. So in conclusion, we can one of the take-home message is actually to know that isometric training can enhance strength, muscular strength, not just at one particular joint angle, but it can enhance through a greater range of movement depending on the joint angle you perform it at. And also isometric training can be used to enhance sports performance of sporting movement. But what I want you to know is that my intention is in no way asking you to replace your training entirely with isometric training. Rather, it is to help increase the tools you have in the toolbox. So coaches and trainers should include isometric training into the training to enhance the overall training by using it to improve on attributes that other modes of training are less effective in, rather than to replace dynamic training entirely. So that wasn't the objective, right? So one example of increasing isometric training is to do the isometric training at the sticking point. So for example, if you want to use isometric training to increase your squat 1 RM, then you perform the isometric squat at the sticking point. Usually it's around 90-degree knee angle. Yeah. And of course, continue to perform the dynamic mode. The isometric mode is just a form of supplementation, I would say. Right. So that concludes my presentation for today. Thank you for your attention.